All right, so I'm going to look at surds in this video. So surds we probably already associate with square roots. When we hear surds, we think square roots, and they are very much associated, but it doesn't doesn't mean the same thing, okay? So for example, what's the square root of 16? It's 4, okay? We might know that already. We can do it in the calculator. The square root of 16 is 4, all right? That means the square root of 16 is not a surd. Okay, so if you get the square root of 16 and your answer is a whole number like this, it's not a surd. Okay, square root of 81 is 9, so that's not a surd either. Okay, so just the square root symbol or square root and surd does not mean the same thing. So if you're getting the square root of a perfect square like this and it gives you a whole number as an answer, that means it's not a surd. Okay, something like the square root of 2 though. So what is the square root of 2? We don't know. We check it on the calculator. The calculator does not give me a whole number as an answer. It gives me the square root of 2. If I press change, it doesn't give me a whole number again. It gives me a whole load. It gives me 2, 4, 6, 8, 9 numbers after the decimal point. And if the calculator could, it would give me an infinite number of numbers after the decimal point. Okay, so the numbers after the decimal point in the square root of 2 will go on forever without repetition, without a pattern. Okay, so that means I cannot write that as a fraction. It means it's an irrational number. It's not a rational number. I can't write it as a fraction. So that means it's a surd. Okay, so the square root of 2 is a surd. All right, the square root of 3 is a surd. The square root of 5 is a surd. The next one I've got down here, the square root of 7. Put it into the calculator, just gives me root 7. I press change, gives me a whole load of decimal points. As I said about the square root of 2, that will go on forever without repetition, without pattern. So the square root of 7 is a surd. All right, so if you put it into the calculator and your calculator does not give you a whole number, or does not give you a fraction, you've got a surd. All right. The square root of 27, is that a surd? Yes, it is. Okay, I can rewrite it as 3 root 3, but root 3 is a surd. Okay, so that means 3 root 3 is a surd and root 27 is a surd. Just be aware that if they ever ask for surd form, this is what they're looking at. Okay, so if you see a question that asks for an answer in surd form and you get square root of 27 as your answer, don't think that's grand, I've got a square root, I can move on now. Just put the square root of 27 into your calculator and see if it simplifies down. So this is its simplified surd form, and that's what the question will be looking for. So root 2 is a surd, root 7 is a surd, 3 root 3 is a surd. All right. One thing to remember about the square root symbol is that, say, the square root of 5 is the same thing as 5 to the power of a half. Okay, that was one of the rules of indices that we would have looked at. So square root and power of a half is the same thing. What that means is I can apply some of these rules of indices to surds. Okay, so because square root just means power of a half, well then these surds are indices as well. So the square root of 2 is 2 to the power of a half. So that means I can apply some of these rules, and that's what I'm going to do next. Okay, I'm going to do some questions where I apply some of these rules or some other stuff. What I would say about the questions I'm about to move on to is you can do a lot of them on the calculator. So I'm going to go through how you would have had to do them in the past pre-calculator. I do think you should kind of understand what you're doing when you work with surds like this, but I'll show you how to do them on the calculator as well. So a few questions or a few examples here, and I'm asked to simplify each of these, or it might say write in the form A root B. So I'm going to write it as a single surd. You'll see here we've got a kind of 2 surds for a lot of them. So simplify as much as possible, or write in the form A root B, or write in the form A root 2 would be your prompt here. So First one I've got is 3 root 2 plus 5 root 2 minus 2 root 2. In this case here, you can treat the root 2 just like it's a variable in algebra, like it's an x or a y. So you've got 3 root 2 plus 5 root 2. You've got 3 of something plus 5 of something. So 3 root 2 plus 5 root 2 is equal to 8 root 2. So it's like having 3x plus 5x. 3 of something plus 5 of something is 8 of that thing. Minus 2 root 2. So then I've got 8 root 2 minus 2 root 2. 8 minus 2 is 6 root 2. Okay, so that's it simplified. All right. Just to say, this only works when you're adding and subtracting the same root or the same surd. So for example, say the square root of 16 plus the square root of 9, okay? So you can't add these kind of surds together. So say, for example, square root of 16 plus square root of 9. One thing people have a tendency to do sometimes is to go 16 plus 9, that's 25. So that's equal to the square root of 25. What's the square root of 25? It's 5. What's the square root of 16 though? It's 4. What's the square root of 9? It's 3. So root 16 plus root 9 is 4 plus 3, which is 7. Whereas if you add them together, root 16 plus root 9, root 25 is equal to 5. Okay, that's not the same thing. All right, this is the correct way of doing it. Okay, so you can only kind of add root 2's and root 2's like this. Okay, so you can't kind of dig into the surd like that and go 16 plus 9 is 25. Okay, just that's a mistake people have a tendency to make sometimes. Moving on then, so 2 root 3 multiplied by 5 root 7, okay? So when you're multiplying two surds together like this, you multiply the 2 by the 5 and the root 3 by the root 7, okay? So 2 multiplied by 5 is 10. And root 3 multiplied by root 7, 3 multiplied by 7 is 21. So that is root 21. Okay, so you can't add kind of unlike surds, if you like that. You can't go root 16 plus root 9 is root 25. You can multiply them though. Okay, so root 3 multiplied by root 7 is root 21. Okay, and it's an application of your rules of indices here that you can do that. So you multiply the 2 by the 5, that's 10. Root 3 by root 7 is root 21. All right. Next one then, so 2 root 5 multiplied by 3 root 5. So 2 multiplied by 3 is 6. Root 5 multiplied by root 5 is root 25. So this is 6 times the square root of 25. The square root of 25, I can simplify that. Square root of 25 is 5. So this is equal to 6 times 5, which is equal to 30. All right, so 2 root 5 multiplied by 3 root 5 is 30. Another thing I would say here is I went root 5 by root 5 is 25. The square root of 5 multiplied by the square root of 5 is equal to 5. So root 5 by root 5 is equal to 5. That's kind of a useful one to be able to kind of do in your head. So root 5 by root 5 is 5. Next one then here, root 72. Okay, so I want to simplify this. All right, what I might do now is I'll go back and maybe do all these on the calculator, because I'll start doing this one on the calculator and then I'll show you how to do it by hand. So as I said, you can do a lot of these on the calculator without kind of using these rules. So 3 root 2 plus 5 root 2 minus 2 root 2. Let's plug that into the calculator. 3 root 2 plus 5 root 2 minus 2 root 2 is equal to 6 root 2. So calculator did that one for me and I got straight to 6 root 2. Next one, let's do this one. 2 root 3 multiplied by 5 root 7 is 10 root 21. So calculator did that one for me as well. Third one then, 2 root 5 multiplied by 3 root 5 is equal to 30. So it gets me straight to the answer. Next one then, so root 72. So as I said, if you're ever asked for an answer in surd form and you get something like root 72, I would plug it into the calculator. And it tells me that that simplifies to 6 root 2. So the square root of 72 is equal to 6 root 2. I'll just show you how you actually get that. So using this rule of indices here, so AB to the power of P is equal to A to the P multiplied by B to the P. So it's an application of this rule here. So what I can do is try and find a perfect square, which is a factor of 72. So any of my perfect squares, so like 1, 4, 9, 16, 30, 25, 36, 49, etc. Is there any of those which is a factor of 72? Yes, 36 is. So I can rewrite the square root of 72 as root 36 multiplied by root 2. So because 36 multiplied by 2 is 72, you can rewrite root 72 as root 36 root 2. What is the square root of 36? It's 6. The square root of 2 is surd, so there it is, 6 root 2. That's the kind of working out of it. So you're splitting 72 up into 36 times 2 and then just getting the square root of 36. Because it's a perfect square, I'm able to kind of work it out as a whole number. But as I said, calculator does it for me as well. This one here, if I was asked to write this as a single surd or write it in the form A root B, look, I'll start with the calculator again. So root 50 plus root 32. There's my answer. The answer is going to be 9 root 2. How do I do it? It's like this one here. I'm looking for perfect squares. So 50. What can I write 50 as? I can write 50 as 25 times 2. So I can rewrite the square root of 50 as root 25 times root 2. Is there a perfect square which is a factor of 32? 16. So plus root 16 times root 2. So I'm just kind of splitting it up into two factors, The square root of 25 then is 5, so 5 root 2. The square root of 16 is 4. So 4 root 2. So now I've got 5 root 2 plus 4 root 2, 5 plus 4 is 9. So 9 root 2, and there's my answer. Okay, so what I would say is if maybe exam question asks you to do this without using the calculator, they'd want to see some sort of working here. They don't want to see you jump straight to the answer. Is there a way I could kind of do it on the calculator and make it look like I didn't do it on the calculator? Well, what if I, instead of just plugging everything in straight away, what if I worked them out individually? Just did root 50. That's equal to 5 root 2. What's root 32? That's equal to 4 root 2. So I'd get 5 root 2 plus 4 root 2. I might be able to do that in my head, or I could type that into the calculator as well. And it gives me 9 root 2. Okay, so you could work out each part individually, and that maybe looks a bit more like you've done it yourself rather than just using the calculator. But again, that's how we do it by hand as well without using the calculator. Just a couple more, and I think I'll be able to do most of these using the calculator, if not all of them using the calculator as well. So just how to deal with surds when you've got two brackets multiplied, so binomial multiplication, two brackets with two terms. So remember, the way I multiply these out is 2 multiplied by 3, so that's 6. 2 multiplied by minus root 7 is minus 2 root 7. Then I multiply root 7 by both terms in the other bracket. So root 7 by 3 is 3 root 7. And then I've got plus root 7 by minus root 7. Positive by a negative is negative. Root 7 by root 7 is the square root of 49. The square root of 49 is 7. Or else root 7 by root 7, that's equal to 7. So know that the square root of 7 by the square root of 7 is equal to 7. Can I simplify this a little bit? Yes, I can. 6 minus 7 is equal to minus 1. 3 root 7 minus 2 root 7 is 1 root 7, or just root 7. So that's that one done. Can the calculator do this one for us? Let's put the first bracket in. 2 plus root 7 multiplied by 3 minus root 7 minus 1 plus root 7. It was able to do it for us. All right. But again, that's how we would do it without the calculator. If you were trying to do it without the calculator, using the calculator without looking like you're using the calculator, gonna go on the calculator, 2 multiplied by 3, that's 6. What's 2 multiplied by minus root 7? 2 by negative root 7. That's minus 2. So you could get each part in the second line using the calculator as well. Question 7 here. So I've got 3 minus root 27 over 3. I want to simplify this. So obvious thing to try and simplify maybe is the root 27. So is there a perfect square I can find in root 27? Root 9, yeah. So I could rewrite this as 3 minus, rewrite root 27 as root 9 root 3 over 3. And then that's equal to 3 minus, the square root of 9 is 3. So I've got 3 minus 3 root 3 over 3. So divide the 3 into both of those terms. So 3 divided by 3 is 1. Minus 3 root 3 divided by 3 is minus 1 root 3, or just minus root 3. All right. Again, would the calculator do it for us? 3 minus root 27 over 3 is equal to 1 minus root 3. So yes, calculator simplifies that one for us. If I was trying to do it by hand and I just wasn't sure about this part here, what's negative 3 root 3 divided by 3, you could just put that part in. So negative 3 root 3 divided by 3 is minus root 3. All right. Last one then that I'll do. So write in the form a root 2. So I want to rewrite this in this form here. So a root 2. So I want to get the root 2 out from under the fraction, okay? I want to get rid of the fraction. So again, I'll do it in the calculator in a second, but just kind of a useful technique that you'll use in a couple of different places in maths as you kind of move through and into leave insert maths. 8 divided by root 2. If I want to get rid of the square root of 2 from under the fractions. That's what they want here. They want me to get rid of this from under the fraction and kind of get rid of the fraction. I can, to get rid of the root 2 from the bottom, multiply the bottom by root 2. If I multiply the bottom by root 2, I need to multiply the top by root 2 as well. All right, so I'm going to multiply this by root 2 over root 2. Now, can I do that? Yes, because what is the square root of 2 divided by the square root of 2? It's just 1. Okay, anything divided by itself is 1. So all I'm doing here is multiplying by 1. All right, I'm doing it in quite an artificial way. That's going to let me get rid of this square root in the bottom, but I'm multiplying by 1, so I'm allowed to do it. By doing it like this, I will be able to get rid of the root on the bottom. So multiplying fractions, top by top, bottom by bottom. So 8 multiplied by root 2 is 8 root 2. On the bottom, root 2 multiplied by root 2 is 2. Now I've got 8 root 2 divided by 2. Well, divide 8 by 2 and you get 4 root 2. So again, the root 2 just operates like a variable here. So like if you had 8x divided by 2, you'd go 8 divided by 2 is 4. Okay, so 8 root 2 divided by 2 is 4 root 2. Let's go back to my question and see if I plug that into the calculator, is it going to get the answer I want? 8 divided by root 2 is 4 root 2, so it does get me there. All right, so look, that's surds. What I would say is you need to know what surds are, especially if you're asked for an answer in surd form, just an awareness that they're irrational numbers. You cannot write them as a fraction. I would be aware of root 2, root 3, root 5, root 7. The first few surds kind of come up quite often. But as I said, a lot of the questions that you're asked to do on them, while there is ways of doing them by hand that I have shown you, the calculator will do a lot of the work for you now.